Welcome to the deep dive. Today we're tackling a really key piece of modern systems,
Yeah,
API gateways.
that's right. Especially crucial in the world of microservices.
Absolutely. Our mission here is to take this concept, which, can sound pretty technical, and really break it down, make it clear, relatable. We're drawing from the source API Gateway in Microservices, a beginner's guide.
It's a good one for getting the fundamentals.
So what is it, why is it important, and what tools do people actually use? That's what we're digging into.
Sounds like a plan.
Okay, so to start, the source gives this really helpful analogy. Think of an API gateway like a receptionist in a big office building.
Okay. I like that.
Yeah, so instead of you, the client, needing to know exactly which office, which phone number for every single department.
Which could be dozens or hundreds.
Exactly. You just go to the main reception desk, you send all your requests there.
And the receptionist, the API gateway, knows exactly who to route your request to internally.
Right.
And that connects directly to microservices because, well, microservices are all about splitting things up. You
Wow.
have small, independent services doing specific jobs.
Like user login or the shopping cart or payments.
Right. Each with its own API. So you inherently need something to manage all that communication traffic coming in.
The receptionist.
The receptionist, yeah. The gateway routes the request to the right service, gets the answer, and sends it back to you. It simplifies the whole interaction, really.
So like the example in the source,
Mm-hmm.
you're using, say, an e-commerce app. You want to see your order history.
Okay.
That request doesn't just, fly directly to some order service somewhere in the back end.
Probably not, yeah.
Instead, it likely goes through the API gateway first,
Mm-hmm.
and it figures out, this needs to go to the order microservice.
And importantly, it does more than just routing.
Right. That's key. It can handle things like checking if you're actually logged in authentication,
Or making sure you're not hammering the service with too many requests, rate limiting.
or even grabbing data from multiple services at once, like getting your profile info and your orders together.
Yes, data aggregation. It can stitch that together into one response for you.
Makes things faster for the user, I imagine.
Definitely. So the core idea here really is how the gateway simplifies things. Communication, security, performance.
Okay.
It pulls these common tasks into one place.
Making this complex web of microservices, well, easier to manage.
Exactly. It's kind of the central control point.
Okay, that sets the stage nicely. But let's really unpack the why. Why is having an API gateway not just like a good idea, but often essential when you're using microservices?
Right. Because the alternative gets messy fast.
Our source definitely highlights that trying to manage direct client many services communication is complex and risky.
Absolutely. Let's break down those core reasons. First up, simplified client interaction.
Oh, yeah.
Imagine you didn't have a gateway. Your app, maybe your mobile app or the website front end. It would need to know the exact network address, maybe the port number, the specific API path for every single microservice it talks to.
Oof. That sounds like a nightmare to maintain. What if a service moves or its API changes?
Precisely. You'd have to update all your clients. It's brittle, error-prone. The gateway gives you one single, stable address,
One front door?
one front door. All requests go there. The client doesn't need to care about the internal layout of the services. Much, much simpler.
Okay, that makes a lot of sense.
Yeah.
Then there's centralized security. You mentioned this earlier.
Yeah, this is huge. The gateway acts as your security checkpoint, your bouncer at the door.
So it can check things like login tokens, API keys.
Exactly. It can enforce authentication, making sure the request is coming from a valid logged-in user or a trusted application. It often handles things like validating JWTs, JSON Web Tokens or OAuth tokens.
And rate limiting, too, to stop abuse.
Right. Preventing someone from overwhelming a service with too many requests, whether it's malicious or just accidental.
So it protects all the individual services behind it.
It does. It takes that burden off them. Security policies are applied consistently at the edge, at the gateway.
Which must make the individual microservices simpler to build, too.
It can, yeah. They can focus more on their core business logic.
Okay, next up, performance optimization. How does the gateway help speed things up?
Well, a couple of ways. We touched on data aggregation. Instead of your app making, say, 3 separate requests, one for user details, one for orders, one for recommendations,
Right.
the gateway can handle that coordination. It makes those 3 internal requests itself, combines the results, and sends back just one response to your app.
Fewer network round trips. Especially important on mobile, I bet.
Critically important, yeah. Less latency, less battery drain. The other thing is caching.
Caching,
Yeah, if some data is requested really often and doesn't change much, the gateway can store a copy of the response temporarily.
like product details maybe.
Could be, yeah. So the next time someone asks for it, the gateway just sends back the cached copy instantly without even bothering the backend service.
Super fast response then.
Very fast. So aggregation and caching, big performance wins. It means a faster, smoother experience for you, the end user, without you even realizing all that complexity humming away behind the scenes.
Nice. What about handling load? Like
Yeah.
when tons of people hit a site at once, load balancing and scalability.
Right. So imagine that big e-commerce sale event.
Yeah.
Traffic spikes like crazy.
Yeah?
You probably don't have just one copy of your product catalog service running. You might have 5, 10, maybe more instances.
Okay.
The API gateway is smart enough to know about all those instances. When requests come pouring in, it distributes them evenly across all the available instances.
So no single instance gets totally overloaded.
Exactly, it balances the load. This is fundamental to how systems scale out horizontally to handle massive traffic.
Yeah.
The gateway is key to making that work smoothly.
It ensures the system stays responsive even under pressure.
Precisely.
And the last big why here is easier maintenance and updates. How does that work?
This is really about decoupling, hiding the internal messiness. Because the clients only ever talk to the gateway acts as an abstraction layer. So let's say you need to update the payment service. Maybe you rewrite it in a new language, or change its internal API significantly, or move it to different servers.
Right.
As long as a gateway knows how to talk to the new version, the clients don't care. They keep sending requests to the same gateway endpoint as before.
Ah, so you can change things behind the gateway without breaking all the apps that use the service.
Exactly. The gateway handles the translation or redirection needed. It makes deploying updates, refactoring services, just general system evolution much, much less disruptive. You're not tightly coupled.
That seems incredibly valuable for keeping things agile over the long run.
It really is. Reduces risk significantly.
Okay, let's recap those benefits quickly for everyone listening.
Yeah.
What does the API gateway give you? We've got simpler communication for clients.
Yep, one front door.
Centralized, stronger security.
Applied consistently.
Better performance through things like aggregation and caching.
Faster experience.
Seamless scalability with load balancing.
Handles the traffic spikes.
And much easier maintenance and updates.
Less disruption when things change internally. Yeah. It's a pretty compelling list.
Definitely paints a picture of why it's so central. Okay, so we know what it is, we know why we need it. Let's talk about the how. How do you actually implement an API gateway?
Right, the tools of the trade.
Our source mentions a few common ones and breaks them down in a way that's pretty beginner-friendly, which is helpful.
Yeah, there are quite a few options out there, but let's look at the ones highlighted. First up, Spring Cloud Gateway.
Okay, Spring, so Java-based.
Exactly. It's built specifically for folks already using Spring Boot for their microservices. It integrates really tightly with the whole Spring ecosystem.
So what does it do? Routes request based on rules.
Yeah, you configure routes. You might say any request starting with orders should go to the order service. Pretty straightforward.
And it supports the other gateway features. Security, rate limiting.
Oh, yeah. It handles authentication, rate limiting, load balancing, all the core stuff. It's built on a reactive, non-blocking foundation, which makes it pretty efficient for handling lots of simultaneous connections.
So why choose this one? If you're already deep in the Spring world, it feels like a natural fit.
That's the main draw. It feels familiar to Spring developers, integrates seamlessly, has good community support within that ecosystem. If your team is Spring-centric, it's often the path of least resistance, and it's quite powerful.
Makes sense.
Okay.
Okay, next on the list, Kong. This one sounds interesting. Open source.
Yep, Kong is a very popular open source option. It also sits in front of your services, routes requests based on paths or headers or other criteria.
And does the usual gateway things, security, logging.
It does. Authentication, rate limiting, logging, monitoring hooks, it covers the bases. But where Kong really differentiates itself is its plugin architecture.
Plugins. Tell me more.
So Kong itself is relatively lightweight, but you can add functionality by enabling plugins. Need OAuth 2.0 security? There's a plugin for that. Want detailed metrics pushed to Prometheus? There's a plugin. Need sophisticated traffic control or canary releases? Plugins.
Ah, so you can kind of pick and choose the advanced features you need.
Exactly. It's super flexible. And importantly, Kong is language and framework agnostic. It doesn't care if your backend services are Java, Python, Node.js, whatever.
So more versatile than Spring Cloud Gateway in that sense. Works with anything.
Generally, yes, its versatility and that powerful plugin system are big selling points. Makes it pretty appealing even for beginners because you can start simple and add complexity via plugins as needed.
Okay, interesting trade-off there. What about the cloud options, like AWS API Gateway or Google's equivalent?
Right, the cloud-based gateways, so AWS API Gateway, Google Cloud API Management, which includes Apigee Azure API Management. All the major cloud providers offer these as managed services.
Managed services,
Mm.
meaning the cloud provider runs it for you.
Exactly. You don't manage the underlying servers or infrastructure. You configure it, set up your routes, security rules, maybe link it to backend services like AWS Lambda functions or containers running on
Like
Kubernetes.
Google Kubernetes Engine, GKE.
Right. And the cloud provider handles the scaling, availability, patching, all of that operational heavy lifting.
That sounds convenient.
It's incredibly convenient. They perform all the core gateway functions, routing, security checks like JWT validation, monitoring dashboards, and they integrate seamlessly with other services in that specific cloud.
So why choose these? The main benefit is that managed aspect. Less setup, less maintenance.
That's a huge part of it, yeah.
Yeah.
Especially for teams that want to move fast and focus on their application logic, not managing gateway infrastructure. They scale automatically, often have pay-as-you-go pricing, and obviously offer the tightest integration if you're already hosting your microservices in that cloud. It lowers the barrier to entry significantly.
So we've got Spring Cloud Gateway, kind of the native choice for Spring users.
Right, deep integration there.
Kong, the versatile open source option with its plug-in power.
Super flexible, works anywhere.
And the cloud gateways, offering that managed convenience and tight cloud integration.
Zero infrastructure hassle, basically.
But what's cool, as the source points out, is that despite their differences, they all nail those core functions we talked about earlier: routing, security, monitoring.
Absolutely. And all of them have pretty strong communities and documentation behind them, which is crucial when you're learning or troubleshooting.
Yeah.
They're all accessible starting points.
So quite a journey through API gateways today. We started with that receptionist analogy
A good starting point.
and unpacked what they are, why they're so critical for simplifying these, potentially very complex microservice systems.
Yeah, turning complexity into something manageable.
We hit those key benefits: easier client interaction, central security, better performance, handling scale, making maintenance smoother.
All crucial for building robust modern applications.
And then we looked at some of the actual tools people use: Spring Cloud Gateway, Kong, the big cloud options.
Giving folks concrete options to explore.
If we kind of zoom out, connect this to the bigger picture, it's pretty fascinating, isn't it?
It really is. These gateways are fundamental, often invisible components that make the digital services we rely on every day actually work smoothly and scale effectively.
We just use an app, and it feels fast, reliable.
Yeah, without giving a second thought to the orchestration happening behind the curtain, API gateways are those silent orchestrators, making
Wow.
complex distributed systems feel simple from the outside.
So maybe a final thought for you, our listener, to chew on after this deep dive.
Mm.
The next time you use an app that feels incredibly quick, or you see a big online store handle a massive sale without falling over, just maybe take a second to think about that hidden layer.
The gateway working away?
Yeah, and maybe ponder this. What would our digital world actually look like? How much clunkier or less secure would it be if organizations didn't use these gateways in their microservice setups? What kind of chaos would ensue?
It's a scary thought, actually. Things would definitely be a lot harder. Something to think about. Well, thank you for joining us on this deep dive into API gateways.
My pleasure. It was a great discussion.